student has planned an experiment to compare the electromotive forces E1 and E2 of two cells using potentiometer. Incomplete circuit diagram that can be used is shown in the figure 1. Other items that can be connected to the circuit are shown separately. Part A. Name the items shown in figures below. We have to identify items given in figures. A is the plug key. A is the plug key. Then B. B is the tap key. The tap key. Then C. C is the two-way switch. Two-way switch. Then D. It is a sliding key. A sliding key. Or we can write its name as a jockey. A jockey. Then E. In the figure, there is a symbol like this. MV. MV means millivolt. Then it is a millivolt meter. But we can identify the center is, the zero is at the center. Then we can write is a center zero millivolt. Center zero millivolt meter. Center zero millivolt meter. Then F has there is a symbol in F, microammeter, microampere. It means it is a center zero microammeter. Then part B, write down the correct letter corresponding to each item given in A above that has to be connected in the system, space 1, space 2, space 3 and space 4. In space 1, we have to use a two-way switch because of we are trying to compare electromotive force of this cell and this cell. In comparing electromotive forces, we have to select this path and this path separately to get reading. Therefore, B is a two-way switch. It means answer is C. Space 1. In space 2 is this space. We have to use, normally we are using a center zero galvanometer. But we know that we are getting the reading when the galvanometer reading is 0. Galvanometer is measuring a small current, but there is no galvanometer in given list. Therefore, we can use center zero microammeter for the space 2. Microammeter is using to measure a small current. Then F for the second space. Then third space is this one. We are connecting sliding key to third space. Sliding key is D. Then space 4 is this one. It is series to the main circuit. We have to connect a switch to turn off the circuit for the space 4. Therefore, we can connect plug key to space 4. Plug key means A. Then using plug key, we know that when plug is connected, the switch is turned on, and when the plug is removed, switch is turned off. Then part C, name the type of cell which gives electromotive force E naught. E naught means this driving cell, and write down its value. We have to use a lead acid accumulator or nickel cadmium cell. But normally in the laboratory we are using a lead acid accumulator. Its voltage should be 2 volts. If we are using a nickel cadmium cell, the EMF of nickel cadmium cell should be 1.2 volts. You have to remember, in meter bridge experiment and this potentiometer experiment, we are using a lead acid cell normally, a lead acid accumulator. Its voltage value is 2 volts. Part D. Why the internal resistance of cell E naught must be very small compared to resistance of potentiometer wire. When considering balance situation, we know that there is a current in this loop. If the internal resistance of EMF is a higher value, there is a high voltage drop across the cell, but there is a low voltage drop between A and B. It means potentiometer wire. But we have to maintain a high voltage between A and B to measure EMF of these two cells. Therefore, we can write the reason for part D. Potential drop of AB wire must be a larger value. Compared to the potential drop of E naught cells, compared with the potential drop of E naught cells. Then part E. In order to perform this experiment, certain conditions have been satisfied with regards E1 and E2 and E naught. What are they? The measuring voltage E1 and E2 should be always less than the voltage of accumulator. Then we can write answer for part E. E1 should be smaller than E naught cell, and E2 also should be less than E naught. Then part F. Compared to a non-ideal voltmeter, a potentiometer is considered as a suitable apparatus for measuring an EMF accuracy. What is the reason for it? When using non-ideal voltmeter, it is measuring the terminal voltage. Terminal voltage means the voltage across corresponding cell when there is a small current through the non-ideal voltmeter. But in this experiment, it means in a potentiometer, we are finding the potential drop of corresponding cell when there is no current through the cell. Then it is the correct EMF value. Therefore, we can write answer for part F. we are measuring potential drop between two terminals of cell when there is a small current through the voltmeter. Through the non-ideal voltmeter. It is not equal to EMF. But when measuring EMF by using potentiometer, we are measuring voltage when the current is zero. It is equal to the electromotive force EMF of cell. Therefore, it is the correct value. In part G, why should the cross-sectional area of potentiometer wire should be uniform? To obtain a constant voltage drop. To obtain a uniform voltage drop. If the voltage drop, if the cross-sectional area is changing along the AB wire, there is no uniform voltage drop. The voltage drop is changing with corresponding cross-sectional area of the wire. In part H, write down the experimental procedure that must follow to determine E1 over E2 ratio. When finding E1 over E2 ratio, we have to connect E1 cell and we have to get the balance length. Then we can connect E2 cell by using the two-way switch connected to space 1, and then we can get again balance length. Then we have to write answer for part H. 1. Connect E1 cell and get the balance length. Then connect E2 cell and get the balance length. We have to obtain balance length separately. Then part 2, if the measurements taken in H1 above corresponding to E1 and E2 cells are X1 and X2 respectively, write down an expression for the E1 over E2 ratio. When using E1 cell, when measuring the potential drop across E1 cell, we can write E1 equals Kx1. X1 is the given balance length, K is the potential drop per unit length. It is the first equation. When using E2 cell, we can write E2 equals Kx2. K value is potential difference per unit length. It is not changing for the corresponding circuit for two situations. We are using the two-way switch connected to space 1 to change E1 and E2 cells. Then we have to get ratio between E1 and E2. We can divide. When dividing, we can cancel out K term. It is equal to x1 over x2. Then part I, Roman number 1. Another student has planned to determine E1 over E2 ratio by using classical method by changing the effective length of potentiometer wire of 6 meters shown in figure 2. What experimental procedure should the student adopt? He has to connect terminal B to each end B1, B2, B3 given in figure, and he has to measure corresponding balance length. Then we can write I part 1. He has to connect B to each end. Each end means B1, B2, B3. Up to BC. And then he can measure corresponding balance length. In part 2, if the gradient of the graph that can be drawn is drawn in part 1 above is Mn, the value of E1 is known. Write down the relationship for E2 in terms of M and E1. We can use this relationship. We have to change x1 and we can measure x2. If we are measuring x2, it is the independent variable. Then we can get x2 equals to E1 over E2 times x1. It is in the form y equals mx. Then we can draw the graph. We have to get x2 for the x-axis in centimeters or meters, x1 for the y-axis in centimeters or meters. The graph should be like this. It is a y equals mx type graph. They have not asked the graph shape, but I have described. Then we can get gradient. Gradient means tan value of this angle. It is given as simple length. Then we can equal gradient of the graph to E1 over E2. Then we can write E1 over E2 equals to gradient. They have given that E1 is a known value. We have to find E2. Then we can subject E2 equals E1 over gradient. It is the answer. If you are getting x1 as the independent variable and x2 as the dependent variable, or if you are changing corresponding physical quantities, dependent variable, independent variable, it also correct. This is only one type of answer. There is another answer we can get by changing x1 and x2. If we are changing x2 and measuring x1, we can obtain the graph like this. Then independent variable is x1. Then we have to subject x1. x1 equals E2 divided by E1 into x2. Now it's also y equals mx format. This one is the gradient. E2 over E1 equals gradient. E2 equals E1 into gradient. It's also correct, but we have to consider correct relationship. We have to decide dependent and independent variables correctly.